Good morning, I'm A. Devasaina. In this lecture, we are going to discuss about root locus, that is, the stability analysis in time domain. This topic is present in the subject control system. Let us solve this problem. The statement is, determine the root locus of the system whose open loop gain is g of s h of s is equal to k divided by s into s plus 4 into s square plus 4s plus 20. This problem is asked in an university November-December 2006. Now we are going to solve this problem. Step 1. First we have to identify the number of poles and zeros. In this problem, there is no zeros. Therefore, the number of zeros z is equal to 0. Now, we are going to identify the number of poles. In this problem, we have 4 poles. That is, in the denominator term, we have s into s plus 4 into s square plus 4s plus 20. This leads to 4 poles. That is, at s is equal to 0 and s is equal to minus 2 plus j4 and minus 2 minus j4 and minus 4, we have 4 poles. Now we are going to identify the number of separate root loci and the starting point and the terminating point of the root locus. Step 2. The number of separate root loci, that is the branches. Here we have 4 poles. Therefore, the root locus branches are 4. Step 3. The starting point of the root locus are from poles 0, minus 2 plus j4, minus 2 minus j4 and minus 4. The terminating point of the root locus is at 0. Here we have no zeros, so the root locus terminates at infinity. Now we are going to identifying the parts of the root locus. Consider point P1. To the right hand side of the point P1, the sum of poles and zeros are odd. So P1 is the part of the root locus. Now consider point P2. To the right hand side of the point P2, the sum of poles and zeros are even. Therefore, the point P2 is not the part of the root locus. Now we are going to determine the asymptote values. Number of asymptotes formula is n suffix a is equal to p minus z. Here we have 4 poles and 0 zeros. Therefore, the number of asymptotes is 4. Now we are going to determine the angle of asymptotes. Formula for calculating the angle of asymptotes is theta suffix n is equal to 2n plus 1 the whole into pi divided by p minus z, where the value of n is equal to 0, 1, 2, it goes on p minus z minus 1. Here n is equal to n suffix a, that is p minus z, that is 4 minus 0, answer is 4. Therefore, for values of 0, 1, 2, 3, we have to determine the angle of asymptotes. Angle of asymptotes calculation is given below. For n is equal to 0, theta suffix 0 is equal to 45 degree. For n is equal to 1, theta suffix 1, its value is equal to 135 degree. For n is equal to 2, theta suffix 2 is equal to 225 degree. For n is equal to 3, its value is theta suffix 3 is equal to 315 degree. Now we are going to determine the centroid value. Centroid is a point where the angle of asymptotes intersects on the real axis. The centroid may be a part of a root locus or it may not be a part of a root locus. Centroid is represented by a symbol sigma. The formula is centroid is equal to sum of real parts of poles minus sum of real parts of zeros divided by p minus z. Here the centroid is equal to, in this problem we have 4 poles. Its real part is 0, minus 4, minus 2, minus 2. And we are not having any zeros. Therefore, the centroid is equal to, sigma is equal to 0, minus 4, minus 2, minus 2, minus the 0 value is 0 divided by 4 minus 0. It is minus 8 by 4, that is minus 4. Now we are going to determine the breakaway point. Breakaway point is a point where the root locus intersects on the real axis. The breakaway point must be a part of a root locus. For calculating the breakaway point, we have to consider the characteristic equation 1 plus g of s h of s is equal to 0. That is, in the given problem, the g of s h of s is given as k divided by 1 s into s plus 4 into s square plus 4s plus 20. Therefore, 1 plus k divided by s into s plus 4 into s square plus 4s plus 20 is equal to 0. If we simplify this equation means we obtain s into s plus 4 into s square plus 4s plus 20 plus k, that is equal to 0. If we further simplify means we obtain the value of k as minus s square plus 4s into s square plus 4s plus 20. That is, the value of k is equal to minus of s power 4 plus 8 s cube plus 36 s square plus 80 s. To find breakaway point, differentiate the value of k with respect to s and further equate the value to the 0. That is, dk by ds is equal to 0. That is, in the given equation, we have the value of k. We have to differentiate the value of k with respect to s. If we differentiate the value of k means we obtain minus of 4s cube plus 24s square plus 72s plus 80 is equal to 0. That is, s cube plus 6s square plus 18s plus 20 is equal to 0. The above equation is having s cube term. We have to simplify this s cube term with the help of trial and error method. The trial and error method of simplifying the above equation is given below. When s is equal to 0, dk by ds value is 80, that is positive value. When s is equal to minus 4, dk by ds value is minus 80, that is negative value. So, when s is equal to 0, the value of dk by ds is equal to 0. Therefore, the breakaway point is minus 2. The roots of s square plus 4s plus 10 is equal to 0 are minus 2 plus or minus j 2.45. The other breakaway points are minus 2 plus or minus j 2.45. The valid breakaway point is minus 2 because breakaway point must be located on the real part of the root locus. Now we are going to determine the intersection of the root locus with imaginary axis j omega. For that we have to consider the characteristic equation 1 plus g of s h of s is equal to 0. In this problem, the value of g of s h of s is equal to k divided by s into s plus 4 into s square plus 4s plus 20. Therefore, we get 1 plus k divided by s into s plus 4 into s square plus 4s plus 20 is equal to 0. If we simplify this equation means we get s into s plus 4 into s square plus 4s plus 20 plus k is equal to 0. If we further simplify means we obtain s power 4 plus 8 s cube plus 36 s square plus 80 s plus k is equal to 0. From that we have to construct the routes array. The value of a0 is equal to 1, the value of a1 is equal to 8, the value of a2 is 36, the value of a3 is 80 and the value of a4 is k. The construction of routes array is shown below. The highest power of s in this problem is s power 4. Therefore, the routes array comprises of s power 4 row, s power 3 row square row, s power 1 row, s power 0 row. For constructing s power 4 row, we have used even number of coefficients a0, a2, a4. For constructing the s power 3 row, we have used odd number of coefficients a1, a3, a5. Now for constructing s power 2 row, we have used the above two rows and we obtained the value of s square row as 26k. And for constructing s power 1 row, we have used s3 row and s square row. That is, s power 1 row is having 2080 minus 8k divided by 26. Now for constructing s0 row, we have used s square row and s power 1 row. Its value is k. To have intersection on j omega axis, any one row should be 0. So make s power 1 row to be 0. That is 2080 minus 8k is equal to 0. If we simplify, this means we get the value of k is equal to 260. Now we have to consider the auxiliary equation. Auxiliary equation is the equation which is just above the s power 1 row. That is 26s square plus k is equal to 0. Substitute the value of k in this equation means we get 26s square plus 260 is equal to 0. That is, if we simplify the value as s square is equal to minus 10. That is, s is equal to plus or minus j root 10. That is plus or minus j 3.16. The root locus intersects on the imaginary axis at plus or minus j 3.16. Now we are going to determine the angle of departure. Since complex poles are present in the given open loop transfer function, therefore it is necessary to calculate the angle of departure also. Angle of departure formula is phi suffix d is equal to 180 degree plus the sum of phi suffix p. Consider the point P3, the complex pole. The sum of phi suffix p is equal to minus phi suffix p1 minus phi suffix p2 minus phi suffix p4. That is minus of 180 degree minus tan inverse of 4 by 2 minus tan inverse of 4 by 2 minus 180 degree. Its value is minus 270 degree. The angle of departure is calculated as phi suffix d is equal to 180 degree plus the sum of phi suffix p. That is 180 degree minus 270 degree. Its value is minus 90 degree. Angle of departure representation is given below. The complete root locus for the given problem is shown below. In this problem, we have calculated the value of centroid as minus 2. The centroid is marked at minus 2. The centroid is a point where the angle of asymptotes intersects on the real axis. The centroid may be a part of a root locus or it may not be a part of a root locus. And we have also marked the intersection of the root locus with the imaginary axis. It is indicated in this problem. And we have also indicated the angle of asymptotes, the entire root locus representation.